Could Earth even function without the moon? I mean, it sounds like a crazy question,
Well,
right?
it does, yeah.
It's been up there forever, billions of years.
Yeah.
We see it, maybe don't even think about it much, but it's pretty wild how much it actually controls things down here.
It's fundamental, truly.
Yeah.
We often just, take our little cosmic neighborhood for granted. The moon's a perfect example.
Right.
And when you actually start digging into what happens if it's not there,
Yeah.
yeah, you find some surprising stuff.
Totally. And that's exactly what we're diving into today. Just imagine it. Poof. The moon's gone. What happens next? What's the domino effect?
Mm-hmm.
We're using research from Earth Without the Moon, a cosmic inquiry, as our guide here. It pulls together quite a bit of science. Remember that NASA Goddard study from 2024?
Oh, yeah, the gravity contribution.
Exactly. They actually tried to quantify its pull.
Right. And look, this isn't just like pulling ideas out of thin air. Scientists have run serious models on this. That NASA study said the moon's gravity is about, 7% of Earth's surface gravity?
Yeah, around 7%.
Doesn't sound like a massive number on its own, maybe.
Right.
But that's 7%. Well, as we'll see, it has some really huge consequences. So picture it. Suddenly, no moon, black sky. What hits us first?
Okay, yeah. Let's start at the start. How did we even get the moon anyway? What's the origin story?
Well, the leading theory, and it's got a lot of evidence backing it up, is the giant impact hypothesis.
The big whack.
The big whack, exactly. About 4.5 billion years ago, early Earth collided with something massive, probably Mars-sized.
Wow.
And all the debris that got blasted out eventually, coalesced under gravity, formed the moon.
Yeah.
So, yeah, a pretty dramatic beginning to the relationship.
Seriously dramatic.
Yeah.
And that set up this gravitational dance you mentioned. We all know the moon causes tides, but how does that actually work? Can you break it down?
Sure, so the moon's pull isn't even across the whole planet.
Mm-hmm.
The side closest to the moon gets pulled harder than the center, which gets pulled harder than the far side. Yeah. And it's that difference in pull. We call it a differential force. That's what stretches Earth slightly and creates two bulges of water.
Two? Why two?
Well, one bulge faces the moon because the water is pulled towards it. The other one forms on the opposite side because the Earth itself is pulled away from the water there. Inertia kind of leaves it behind.
Okay, makes sense.
And as Earth spins underneath these bulges, we move through them, experiencing high and low tide.
So the moon's really conducting the whole orchestra, the ebb and flow. The sun's involved too, though, isn't it?
It is, yeah. The sun has gravity, obviously, and it creates tides too.
Yeah.
But it's much farther away, so its tidal effect is weaker. Only about 40% as strong as the moon's.
Only 40%, so lose the moon.
And your tides basically collapse. There was a simulation, University of Miami, 2025, I think. They projected tidal ranges dropping from, several feet in many places down to less than 1 foot.
Less than a foot. That's almost nothing. I can picture the beaches looking weird, but what does that actually do, the practical effects?
Ecologically, immense. Think about the intertidal zone, that strip of coast that's underwater, then exposed, back and forth.
Yeah, tide pools and stuff.
Exactly. Crabs, oysters, mussels, seaweed. Tons of species are specifically adapted to that cycle. They need it for food, for shelter, reproduction, avoiding predators. A study in Palawan in the Philippines found something like 60% of the life in that zone depends on the tides.
60%?
Take away the tides, and that whole ecosystem foundation just crumbles. You'd see mass die-offs, massive disruption moving right up the food chain.
That's huge. And it's not just the creatures right there, I guess. It spreads out.
Oh, absolutely. And it's geological, too.
Hmm.
Tides move sediment. They erode coastlines. Without strong tides, things get stagnant.
Stagnant, like less change. Is that bad?
It sounds stable, but it can be ecologically bad, yeah. Coastal wetlands, for example, rely on that tidal flushing to circulate nutrients and prevent salt buildup. A Geological Society of America report, I think it was 2025, predicted places like Louisiana's wetlands could lose maybe 30% of their biodiversity without that flushing.
Wow. So still beaches, collapsing wetlands. What about us, humans?
Well, think about ports. So many ports around the world are built, assuming certain tidal ranges for ships to get in and out safely.
Right, deep water access.
Exactly. If the water levels drop drastically and predictably, well, unpredictably low, I guess, many ports just become unusable. Huge hit to shipping, trade, especially in complex coastal areas like Southeast Asia.
Okay, so no real tides, Wrecked coastlines, messed up shipping. That's a lot already. But the moon does more, right? You mentioned Earth's wobble.
Yes, this is another really big one. Earth spins on an axis, and that axis is tilted about 23.5 degrees relative to our orbit around the sun.
That's what gives us seasons.
Precisely.
Yeah.
And the moon's gravity acts like a stabilizing hand, keeping that tilt relatively constant over really long time scales. Think of it like a gyroscope.
Okay, a cosmic gyroscope. So if we lose the gyroscope,
Uh-oh. Yeah. Without the moon's stabilizing pull, Earth's tilt could go kind of haywire. Models, like one from ESA in 2024, suggest it could swing wildly over tens of thousands of years, maybe between 0 degrees,
0. So no tilt.
and maybe up to 85 degrees.
85, that's almost tipped over on its side. What would that even look like, climate-wise?
Total chaos. Imagine 0 tilt. The poles would get very little direct sun. The equator, constant sun. No real seasons as we know them. Now imagine 85 degrees.
Oh, man.
Parts of the planet, like Antarctica, could face the sun continuously for months, maybe years. Massive ice melt. Meanwhile, the equator could be plunged into prolonged darkness and cold.
That sounds like sci-fi nightmare fuel.
And the weather. A Max Planck Institute simulation suggested just a 10-degree increase in that Tate variability could potentially double the frequency of extreme events. Hurricanes, droughts, floods, within decades.
Double the hurricanes. And farming, forget about it, right? If seasons are totally unpredictable.
Absolutely, forget about it. Growing seasons would be destroyed. You would likely see global food shortages, mass migrations, people desperately trying to find somewhere, anywhere, with a somewhat stable climate.
It really hammers home that our stable tilt, thanks to the moon, is just fundamental for, well, for civilization.
It really is. It underpins the relatively stable climate we've enjoyed.
Okay, so no tides, wobbly planet. What else? Oh, the length of the day. I read the moon is actually slowing us down.
It is, yeah. It's a process called tidal breaking. Remember those tidal bulges?
Uh-huh.
The moon's gravity tugs on them, and because Earth is spinning, those bulges are slightly ahead of the moon in its orbit. That creates a tiny, tiny gravitational drag.
Like brakes.
Exactly like brakes. It slows Earth's rotation ever so slightly. It adds about 1.7 milliseconds to the length of our day every century.
That's not much.
Seems tiny, right?
Yeah.
But over billions of years, it adds up significantly. Days used to be much shorter.
Okay, so if the moon vanishes, the brakes come off. Does Earth speed up?
Not speed up, but the slowing down would dramatically decrease.
Yeah.
There's still a tiny bit of friction inside Earth, and the sun has a very weak tidal effect, so it'd still slow down a little. But without the moon's main contribution, the process stalls.
So what happens to the day length long term?
Well, one study, Nature Geoscience 2024, estimated that without the moon, over millions and millions of years, the day could eventually stretch out to be longer than 48 hours.
48 hours.
Yeah. But the more immediate issue, even before days get that long, is disrupting the rhythm of life.
Our internal clocks, circadian rhythms.
Exactly. Everything, from humans to plants to microbes, has evolved around a roughly 24-hour cycle. Light, dark, temperature changes. It governs sleep, metabolism, growth, everything.
How would a longer day mess that up, say even 30 hours?
It throws everything out of whack. There's an experiment, UC Davis 2025, with Arabidopsis plants. They put them on simulated 48-hour light-dark cycles. Their growth rates dropped significantly, like 30%. Their internal clocks just couldn't cope. They didn't know when to do photosynthesis efficiently, when to conserve energy.
So plants get confused. What about animals? Us.
Big challenges. Nocturnal animals, like bats maybe? Think about bats in Baguio City. Suddenly they have much longer nights. Does that make them more vulnerable? Change hunting patterns. For humans, yeah, our sleep cycles are deeply ingrained. A drastically longer day-night cycle could lead to widespread sleep disruption, stress, fatigue, maybe even health issues like insomnia. There was a Journal of Sleep Research article on this.
It really is all connected, isn't it? No moon leads to the wobble, leads to crazy climate, and it messes with the basic day-night rhythm of life. Speaking of crazy climate, let's circle back to that. You said the moon moderates the wobble.
Yes, that stabilizing effect is just crucial for long-term climate stability. Take away the moon, the wobble increases.
And extreme weather becomes the new normal.
Pretty much. Instead of relatively predictable seasons, you get wild swings. That 2024 NOAA climate model we mentioned, it projected potential global temperature shifts of 5 to 10 degrees Celsius over centuries.
5 to 10 degrees, that's huge compared to the changes we're worried about now.
Exactly. That scale of change, happening relatively quickly in geological terms, would trigger intense ice ages, scorching heat waves, completely unpredictable cycles, ecosystems wouldn't stand much chance of adapting.
Yeah, you mentioned ecosystems are already stressed. What kind of specific damage are we talking about with those kinds of temperature swings?
Think about coral reefs again. The Great Barrier Reef is already struggling with maybe 1 or 1.5 degrees warming. A UNESCO report warned 90% could bleach with just 2 degrees. Now imagine 5 or 10 degrees swinging back and forth.
Total wipeout.
Likely. And on land, rainfall patterns would shift drastically. Areas like the Amazon, which depend on consistent rain, could dry out, potentially transitioning to savanna.
And again, food. If the climate's that chaotic, reliable agriculture is impossible.
Impossible. That World Bank analysis predicted maybe a 20% drop in usable farmland, food shortages, displacement, potentially hundreds of millions of people affected. It's a grim scenario.
It really is. It paints the moon as this silent guardian, just keeping things ticking along smoothly enough for life like ours to exist.
That's a good way to put it.
And the fallout from losing it just cascades everywhere. What about other ecosystem effects beyond just climate?
Well, ocean mixing is critical. Those tides we talked about. They don't just move water levels up and down, they actively stir the oceans, especially near coasts.
Stirring. Why does that matter?
It brings nutrients up from the deep ocean to the sunlit surface waters. That's food for phytoplankton.
The base of the food web.
Exactly. Phytoplankton are the foundation. A study in limnology and oceanography estimated tidal mixing drives maybe 25% of that nutrient upwelling in coastal zones.
So weaker tides mean?
Less mixing, less nutrient supply, potentially a big drop, maybe 15–20% in overall marine productivity.
Yeah.
Fewer phytoplankton means less food for everything else, from tiny zooplankton up to fish, whales, and us. Big impact on global fisheries and food security.
Wow, okay. And on land, any other knock-on effects?
Pollination is another potential issue. Think about bees, butterflies. Their activity is often timed very closely to the daily light and temperature cycles.
The 24-hour clock again.
Right. If you suddenly have much longer days or totally unpredictable weather disrupting flowering times, how does that affect pollination? An experiment, Proceedings of the Royal Society, simulated longer day cycles and found about a 40% drop in pollination efficiency.
40%. That could devastate agriculture.
It could lead to the collapse of many agricultural systems that rely on these pollinators. It's another way everything unravels.
It just feels like dominoes falling. Habitat loss from climate change, food shortages from failing agriculture and fisheries, extreme weather.
Add in direct threats to wildlife, adapting to new day lengths, new climates, lack of food, polar bears, elephants, migratory birds. Everything is interconnected.
And for humans directly, beyond food and climate refugees.
Well, coastal cities again.
Right.
Places like Miami, Manila, they're built with tides in mind as a buffer.
Right.
Lose that buffer, and they become way more vulnerable to storm surges, flooding, general sea level rise.
Right.
That Asian Development Bank report mentioned potential trillions in economic losses just in Southeast Asia if marine ecosystems collapse and coasts become more hazardous.
Trillions. It almost makes you think long term. Would humanity even consider leaving space exploration as a plan B?
I mean, you could see how it might eventually push in that direction out of sheer necessity, but realistically, that's so far beyond our current capability on the scale needed. It's not a practical solution to this kind of immediate planet-wide catastrophe.
So back to the big question. Could Earth survive? The short answer seems like maybe technically, but not in any way we'd recognize.
That sums it up pretty well, I think.
Yeah.
Some really tough microorganisms, maybe things like tardigrades that can survive extreme conditions.
Yeah.
They might hang on.
Water bears.
Yeah, water bears. But complex life, the ecosystems that support us and the incredible biodiversity we have now, they face, frankly, existential threats.
It really drives home how important the moon has been for, what, billions of years in keeping Earth, well, habitable.
Absolutely. This stable environment we think of as normal is actually a result of this quite delicate cosmic balance.
Is there any chance things could settle down eventually, millions of years down the line?
Possibly. Some scientists, like in a Planetary Science Institute thought experiment, suggest Earth might find a new equilibrium over millions of years. The core and mantle might adjust, the climate might eventually stabilize into some new pattern. But that time scale, it's irrelevant to us. Human civilization, complex life, wouldn't survive the initial chaos and instability to see that new equilibrium.
It's a humbling perspective. Does looking at other planets tell us anything? Like Mars or Venus?
It does offer some comparisons, yeah. Mars doesn't have a large moon like ours. And guess what? Its axial tilt varies wildly, maybe 10 to 60 degrees.
Contributing to its harsh climate.
Exactly. It's likely a big factor in why Mars is so barren today. Then there's Venus. No moon at all, spins backwards slowly, runaway greenhouse effect.
Mm.
It's hellish. Now, there are other factors there, of course, but the lack of a stabilizing moon probably didn't help.
So Earth's setup is kind of special.
It seems that way. An astrophysical journal analysis pointed out that having a moon that's relatively large compared to its planet ours is about 181st Earth's mass seems pretty critical for long-term habitability. It might be a key part of the rare Earth idea. Wow. It gives you a whole new appreciation for the moon, doesn't it?
Yeah.
Not just a pretty light in the sky, but this vital anchor. Absolutely. A vital anchor for planetary stability, for climate, for the rhythm of life itself.
So the main takeaway from this whole deep dive, the moon's influence is just incredibly deep, incredibly interconnected, far more than we usually think. And imagining it gone really shows how maybe fragile this planetary balance actually is.
Precisely. It's a powerful thought experiment. It really makes you appreciate the intricate systems that sustain life here and the moon's, quiet but essential role in that whole grand system.
Definitely. So as we wrap this up, thinking about a moonless Earth, I'll leave you with this question to chew on. We've talked about the chaos, the collapse, but thinking really long-term, millions of years, what kind of life, if any, do you think could actually adapt and maybe even thrive on that radically different Earth? It's a fascinating question about resilience, adaptation, and the limits of life itself.